All right, guys, welcome back to the Next Minute channel. Today we're looking at our past paper, paper 2. Specifically looking at number 8, and this is a 2007 paper. So let me just make a note of that. It's actually a January paper. So it's January 2007. All right, so I'm just added this is when I'm a student and kind of skip over this because I tell her that they don't repeat. But then I say, you know what? Let me just do it. So it just in case Csec gets smart and repeat the question, you guys can have a little head start. So let's read what the question says. It says a large equilateral triangle is subdivided into sets of similar triangles by using the following procedure. The midpoint of the sides of each equilateral triangle are joined to form a new set of smaller triangles. The procedure is repeated many times. The table below shows the result when the above procedure has been repeated twice. That is when n is equal to 2. All right, so let's see what it says now. So you see the result. So result 1 for 0. When n is 0, we got 1. All right, when n was 1, they got 4. And this is the representing number of triangles. So right away, you try to figure out like a pattern here. And when n are 2, you got 16. So your task is to find out when n is 3, when n is 6, so what else? And they give you this, and you have to figure out n here. So for 3, you have to figure out n. You see where side say, and you're supposed to figure out what this when it's m. All right, so let's get right to it. If you figure out it already, you can leave it in the comment section. All right, so let's go. So this is how I would approach it. First, I would inspect these numbers. So we have 1, and then we have 3, and then we have 16. So right away, whatever they're doing, it must be consistent for all. So I know persons are going to say right here they add 3, and then they add 8. But that's not consistent, right? So I'm thinking it will be 4 to the 0. So you do a little hypothesis, because you know say 4 raised to any number raised to 0 or 1. Let's see if it's would get this. It will be 4 to the 1, which is indeed equal to 4. So we just have to try it with this one now. If it's consistent with this one, you know, so yeah, I eat that, you know. 4 times 4 is 16. So it simply means that. So for the third one, it would be 4 to the 3. By the way, guys, if you can figure it out from this, it would be awesome. All right, not my strong point that. So, but I can inspect the numbers, so it would be 4 times 4 times 4. So this will give me what? 64, 16 times 4. Yes, so for 3, it will be 64. All right, let us see if we can figure out for the next one now. All right, so this is the first one. So you get probably 1 mark for this. I will look further down. And then for 2 now, you're going to figure out when you have 4 to the 6. I think I need a calculator here. You know? So it's 4 times 4 times 4. So whatever n is, that's the power of what are 4 raised to the 4. So let's see, 1, 2, 3, 4, 5, 6. I can't freestyle this. 4, 4, 16, that's 64. No, I can't freestyle it. 256. Think 1024. Hold on, guys. Let me get my calculator. Whoa, I gave my students some of these in class. So let me see. 4 to the 6. So it's 6 times. So All right, so 4 times 4, that's 1. 16 times 4, 64 times 4, 256 times 4, 1024. That's to the fourth. All right, times 4 now, 4096 times another 4. So it's actually 16,384. So for this one, it's 16,384. Very nice question though. Yeah, it have some little thinking in it, all right? So now we have this number and we want to figure out what would represent n. So what I would do, since I already know that 4 to the 6 is this number, I would just continue multiplying by 4 with my calculator until I get it. Let me see. No matter of fact, if I don't get this, when I do that, continue multiplying by 4, it means that everything would be incorrect. All right, so we have 4 to the 6 already. I can multiply by another 4 times 4. So that's 65. Right. I want more one. So it's actually 1, 2, 3, 4, 5, 6, 7, 8. No, I think this is incorrect. I think that was to the 6. 1, 2, 1, 2, 3, 4, 5, 6. I think this one was to the 7th. Hold on. Me a blind, you know, me a blind. 1, 2, 3, 4, 5, 6. It's actually this is incorrect. It's 4,000. I think I did one too many. So it's actually because I literally do them, guys. My calculator don't have this or something. So it's actually 4,000. Let me see that figure. 4,096. All right. So that means when I multiply, so this will be to the 8 then. So right here would be to the 8 because I had 7 on it first. All right. So now we need to figure out for the last one. Well, let's see, so see it. Calculate the number. Yeah, we did that already. When n equal 3, we put in that was 16. When n equals 6, we got what, 4,096. We don't even have to put them in here so already, because we get them in the table. And for this, that are 8. So we got 8 there. So we need to figure out the last one that says determine the number of small triangles in a shape after carrying out the procedure m times. All right, remember we said that it's 4 times whatever number. So this time the number is m. So all we do, say 4 to the m, and that's it. We don't know what m is, but whatever it is, it's gonna be the power. So let's write that. And you see, guys, this is actually 10 marks. So, and this is what come in the reasoning part. So when you see you get a A in reasoning, if you get all 10 marks here, you're very good with the reasoning aspect of it. So look out for the puzzle. They don't normally repeat it, but I don't think it hurt knowing how to do it. All right. So guys, thank you guys so much for watching. This is the next minute to out, no doubt. Please ensure so you like the video, guys. I will put effort going to them something here, you know. People watch the video and I like it, but I understand that. Just like the video for me now. Thank you. All right, if you're not subscribed, do that now for me now so you can get more. I'm out. No doubt.